Hello, everybody. We are live. So welcome to the EMEA live stream for Azure Cosmos DB Conf, the first conference for Cosmos DB. So Azure Cosmos DB Conf was organized to provide a live stage for global Cosmos DB communities to share and discover each other. So over the next 3 hours, you will see and hear from customers and community members who have built some amazing apps and services. And they're going to show you what they've built and what they're learning, what they learned building on Cosmos DB and for the cloud. So you'll hear from partners also who have built tools to make building applications and services with Cosmos DB better and easier overall. So I'm Theo. I'm a PM on the Cosmos DB team. I want to introduce a couple of my colleagues, Gal and Stefani. They're also PMs on the Cosmos DB team. Gal, do you want to take us through the format today?
Sure. Thanks, Theo, for the introduction. Hi, everyone. I'm Gal Levy, and I'm a PM on the Cosmos DB team. In this last live stream for the Azure Cosmos DB Conf, we'll hear from community members from across the region. If you missed any of the live streams, don't worry. We will have these on demand available shortly. For each of these live sessions over the next 3 hours, we'll have a live Q&A link for Q&A with the speakers. If you'd like to ask questions, be sure to join the live stream on Learn TV. And now Stephanie to introduce our first speaker.
Yes, thanks everyone. Thanks, Gal. I'm so happy to be here. So super exciting to be here with our first conference. So first off, we're kicking things off with Mikhail Shilkov. He's from the Pulumi team, and he's going to be telling us about building modern infrastructure for modern apps.
Hello, friends. Happy to be here at Azure Cosmos DB conference and to talk about modern infrastructure as code and how you can apply it to Azure Cosmos DB and other cloud systems that surround it. So let's jump to my slides. When you use Cosmos DB in your systems, you combine it with many other components as well. You develop your applications that are deployed to the cloud compute services, let's say Azure Kubernetes services in my demos today. Maybe those applications are structured as microservices with all the machinery that you need to run that. You use also other managed services, maybe in multiple geographic locations, because that's the strong side of Cosmos DB, or maybe even across multiple vendors. In any case, you need to deploy those applications and infrastructure components, of course. And today I want to show you how you can use, for example, C# to provision cloud resources. And I'm a software developer working on an open source tool called Pulumi, which allows you exactly this: deploy Azure Cosmos DB and all the parts of your applications from .NET or other programming languages. So three cool things about Pulumi that I want to emphasize today. First is that if you come from a developer background, you can use all the skills, tools, and habits that you already have as a developer. Now, my demo is going to be in C#, but that's just because I needed to pick a language for the demo. You can also use TypeScript or Python or Go, your favorite language in your own projects. With that, I want to show how developers and operators can and need to work together to be productive in today's complex cloud-native world. And finally, with our APIs, you get access to full API servers of both Azure and Kubernetes, full coverage of all the services and features as soon as they are released by Microsoft or by the Kubernetes community. So let's get going. Azure has dozens of services and hundreds of resource types. And this slide just shows a small subset of them. To create all of those, of course, you can get started with Azure Portal or the Azure CLI. These are great things to explore stuff, but they are not a great option for production deployment because they are very manual and hard to reliably reproduce over and over again. Looking at Azure Cosmos DB is a great example of the breadth of features and management aspects that you need to take care of. You have to manage accounts, databases, collections, APIs. If you are more of an IT or DevOps person, you control things like replication, networking, security, backups, scalability, monitoring, cost, you name it. As a developer, you're probably more focused on fine-tuning your collections with indexes, deciding on consistency levels, managing data flows, integrations with other services, and so on. So it's a bad idea to use ad hoc manual approach to manage all of that in the real production applications in real organizations. Instead, you may have heard of infrastructure as code, where you describe your resources, your cloud resources, in some machine-readable format. And then there is a tool that deploys the resources for you from your definitions. You may know of ARM templates where this machine-readable format is JSON. There is now also Bicep, which introduces its own DSL language. In Kubernetes, that would be YAML files and Helm templates, for example. What we at Pulumi suggest is that you modernize your approach and start using programming languages instead of text files. The benefits are, for example, using the rich toolchain that are used to, like compilers, IDEs, refactoring, and so on, that I'm going to show in a demo. And then importantly, you can create reusable abstractions like functions, classes, libraries, share them with your colleagues and the larger community as well. So you can do even things like unit testing with your code for your infrastructure programs as well. How cool is that? Pulumi supports multiple cloud providers, AWS, Google Cloud, and others, but our Azure story is special because just yesterday, actually, we introduced the general availability of our native Azure provider. It supports all of our languages and runtimes, but even more importantly, our SDKs are automatically generated from Azure Open API specs that Microsoft publishes. That means that you get access to all properties of all resources of all Azure services as soon as the specs are publicly released, literally on the same day, sometimes even like before they are released, actually. I suspect you haven't heard of the Azure Web PubSub service. Apparently, that's a vNext service for SignalR, which is not yet announced as far as I know, but we already have APIs for it because Microsoft already published the Open API specs for it the other day. And we also have a tool where you can take an ARM template and convert it to a draft of your C# or TypeScript program that you can then adapt to your needs with a low effort. So here is my first example of how we can define Azure resources with C# in Pulumi. Each resource is basically a constructor call with a name and a bunch of properties. In this case, I define two cloud resources, a resource group, a container for other resources, and the Cosmos DB account. Note how I use lots of enums here instead of like magic strings that you would use in JSON. And this is all compile time checked. So if you make a typo, you will get a compiler error and it will be immediately apparent in the ID. Also note how I use the resource group variable in the definition of my database account class. And that usage by itself creates an automatic dependency between resources. It's not the order of statements in my program. It's not imperative code. It's declarative sort of that defines the deployment order. It's just those dependencies through the variables that define the actual deployment sequence. Now, a lot of companies these days also use Kubernetes as their application platform. With Pulumi, it's the same story for Kubernetes as for Azure. You can manage 100% of your API surface of Kubernetes, and you can deploy actually both Azure and Kubernetes from the same program, as I'm going to show in the demo. And all with the safety and pleasure of working with .NET or your favorite runtime. So actually, these are all my slides for today, and the rest is going to be my demo. In the demo, I'm going to use .NET 5 and C#9 to define a Pulumi program that provisions an AKS cluster, a Cosmos DB account with MongoDB API. Then it deploys a to-do app with a Helm chart that uses that Cosmos DB as a data storage. It's a to-do app. Obviously, it's a very simplistic version of real-world applications. But as you can see, there is already a bunch of moving parts that I have to manage and integrate correctly. So I'm switching over to my Visual Studio, where I have I hope you can see it. Yes, you can see it now. So I'm on my Visual Studio where I have a C# project bootstrapped, and it's a normal .NET 5 project and executable program. And you can see that I have a bunch of NuGet references. They are all from Pulumi, different providers of Pulumi, one Azure, manage Azure resources, one can manage Kubernetes resources, something to create Azure AD accounts, for example, SSL keys that I need to create a Kubernetes cluster, and so on and so forth. So my program is empty at the moment, and I have a couple of snippets to avoid typing and sort of get going faster. At first I just define my program. I use a bunch of using statements to get all the packages right. You can see I'm going to create a bunch of Kubernetes objects. And then I'm using the top level statements as my console application code. And all the program just consists of one line, basically. It's saying, Pulumi deployment run async, and please deploy the stack that I define below. And stack is a class which derives from base class stack from Pulumi namespace. And this is the constructor, and I need to define my Azure resources in here. So my first Azure resource is going to be a resource group, of course, because I need to provision other resources. And that's all I need to define a resource group. I just give it a name. I have a config file already on my machine that says that my default location is West Europe, where I reside. So that's all I need to start deploying my application. And actually, I can now switch over to PowerShell console. I'm on the folder with that project that I just created. And now to deploy this code, I need to type Pulumi app in my console. Maybe I will make it a bit bigger. And then hit enter, and then Pulumi runs. It compiles the program that I just created in Visual Studio, and then it will run it as a console application. And it will get the definitions of resources that I have there, and will show me the preview. So nothing is being deployed yet. It's just, oh, okay. So I don't have, that's a good thing. I don't have location configured in my config file, so I need to run another Pulumi program that will say that I'm actually in West Europe, so you can see how it's done. Okay, I'm now in West Europe. Let's try it again. Pulumi app again, it compiles again, runs my code, and will again, this time it should show me the preview of which resources are about to be created in Azure. Yes, I can see that it wants to create sort of two things. One is just a stack that is like a high-level container of my resources. It doesn't create anything in Azure. And then the second one is a resource group. This looks good to me, so I hit yes. And this time my program runs again, and Pulumi will go ahead and actually provision resources in the cloud for me. So it should create a stack, which is no open in terms of Azure. And then it creates a resource group, and it took me about 9 seconds to do all of that. Okay, this looks good. Switching back to my Visual Studio. After resource group, I want to provision my Cosmos DB, of course. So I have a snippet that creates a Cosmos DB, MongoDB database, because that's what my application is going to expect. It expects a MongoDB. It actually doesn't know that's going to be Cosmos. So I just provision a MongoDB API for Cosmos, very powerful feature. And then I can go proceed with deploying my application. Okay, so I defined a new resource, and actually it's not one resource, it's two resources, and I have a helper component here in my program. It's not a class, and it's a good demonstration of how you can create abstractions in your own code. So I created a class which does the nitty-gritty details of provisioning a Cosmos DB account with all like offer types and kind of MongoDB, and defines a consistency layer and so on and so forth, locations where I want to deploy. And then the second resource is the database that I need to create for my to-do app, and it's called to-dos, of course. So now when I edit this component call to my program still looks very simple, so I can reuse this class over and over again. I can switch back to the CLI and run Pulumi app again. And this time the same happens. It runs my program. It will see that now I define two resources. One is a resource group, actually three resources, a resource group, a Cosmos DB account, and a database. And it compares that definition with the previous deployment where I already have a resource group deployed to Azure, it now shows me the difference between what I have in Azure and what I have in my program. And the difference is that it's going to create a database account and a MongoDB database, and it will not touch my resource group because it's already there. So I don't have to write, like, I will hit yes to start the deployment. I don't have to write like migration script from state A to state B. I just keep adding more and more resources to my program, and then Pulumi takes care of the state and comparing the previous state with the next state and figure out the best path forward. And that's a great difference with, for example, using Azure SDK directly, where you would have to like create an imperative step-by-step program of what exactly to be provisioned this time, or versus like upgrading from version A to version B. While in Pulumi, you define desired state configuration, where you keep adding more and more resources, and then the state is taken care of by the CLI. So actually, as you may know, provisioning a database account takes about 5-10 minutes, I don't know. So I'll leave it running here, and we'll go back to Visual Studio to complete my project. So next thing that here is a AKS cluster. I have another component that abstracts away some nitty-gritty details of provisioning a Kubernetes cluster for Azure Kubernetes servers. It needs like SSL keys, Azure AD applications, some other resources, and of course the managed cluster itself. But it's all hidden in this component that I created, and it just need to pass a resource group, Kubernetes version that I want, node count, and node size for my pool. That's about it. And now I can start provisioning resources to the same to this AKS cluster from the same program. One of the outputs of that component, if I type here, you can see that I can use an IntelliSense and everything, is going to be kubeconfig. And that's the kubeconfig that's going to be calculated after the cluster is deployed. And I can use that kubeconfig immediately, even before the cluster is deployed, to start creating Kubernetes resources here. For example, I need to put a connection string somewhere. So I create a Kubernetes secret that contains a string of my connection string to the Cosmos DB MongoDB API. And you can see I'm using a function here, C# function, to format that connection string. And that's another benefit of using C# or other general programming language, as opposed to JSON. You can just write a simple function or a class with methods, as you would do in your application, and do whatever you want there, format strings or load something from external configuration file, or make a call to the external API if you want, and like format the thing that you need to deploy as a secret in the Kubernetes and just assign it to a property. And then the next step is going to be deploying a Helm chart. There is a Helm chart, just a demo Helm chart by Bitnami, that deploys the to-do app given a MongoDB connection string. And in this case, I say that, hey, it needs a value called external DB, and I will point it to the secret that I created on the previous step, and it will read the secret value at runtime from the Kubernetes when it runs in Kubernetes, and we'll create a load balancer in front of it, and it's going to be my application. Instead of that, you could deploy your ASP.NET app or whatever kind of application you create to connect to Cosmos DB. This is just very easy to demo. And then the final step in my program, I'm almost done, is to export the URL of the resulting application, of course. Like I can get it from a service object in Kubernetes, take its load balancer, ingress IP, all of that with C# again, all with types and IntelliSense. If I make like a typo here, it will complain that there is no property in toGress. And so I get a very fast feedback loop while I'm developing code for this. And I can be confident that it sort of works before I even start deploying. And then I assign that IP plus an HTTP to the endpoint output, and that's how I define the output of my program. So when my deployment is done, it will print out the endpoint at the end of the deployment, and I will be able to use it immediately after. So that's it. That's a complete program. I'll just hit save and switch over to the CLI. Let's see if, yes, Cosmos DB actually provisioned. I was lucky it got created in 4 minutes. So I can run Pulumi up again. Now it compares the state, the previous state of my deployment with the database versus the current program, and it should figure out that it should deploy an AKS cluster and a bunch of Kubernetes objects to it. Let's see what the preview shows real quick. You can already see it computes. Yeah, okay, I'll scroll up a bit. So it has like a AKS cluster with a managed cluster in container service. Also, it has a Helm chart that I defined and a secret that I defined with connections. So this looks good. I'll hit yes, and don't have time to wait for AKS. So I'll just switch over to the next tab in my PowerShell, where I had the same deployment but already done and finished. It will take about 3-4 minutes more. So in the end, all this is created, and you can see that the output that I see here is the endpoint to my application. And if I switch over to the browser, this is the to-do that we deployed. And like if I do something add here, this is stored already in Cosmos DB that I just provisioned with my C# code. All right. So quickly back to the slides. So that was the case where I deployed all the components from the same application, from the same program in C#. In practice, it's not likely that the same person in your organization is going to deploy all those things at the same time. So what we see more in the larger companies or even in smaller companies with multiple teams, that they have some specialization there. Some people work on like underlying things like Kubernetes clusters, but also security, networking, storage, monitoring, scalability, multiple environments, creating guardrails for their developers. And these are like platform teams that are working on the internal platforms for their applications in the company to be deployed. And then application developers, they usually don't really want to care about all those details. They care about the application code, the data that they manage, like messaging, login, performance, and integrations with different services internally or externally. So there are multiple roles. And how this translates in Pulumi is that probably a platform team will create a stack or multiple stacks where they define all those low-level details, and they will deploy them on their cadence when they want and with their permissions and their credentials. And then they will share something like kubeconfigs and other connection strings with application developers, and then they can import it and sort of based on that deploy their Kubernetes services, deployments, and so on to the clusters that were already provisioned and ready to go. And even with Pulumi, platform teams can create like the components like I showed you, where they create the blast configurations of application deployments, for example, and then they can share it as a NuGet package internally or to the community, and the application teams will be able to get started quickly and use those in their applications. Last very quick demo for the 2 minutes that I have left is automation API. The demo I showed you before was using our CLI, so Pulumi CLI. You have to go to PowerShell or other CLI and run our command Pulumi. What you can do instead is to drive the complete deployment from your C# program, like in this case. So this code speaks to the case that I just described, where you have a platform team and two applications team that build on top of it. So it has 3 stacks. One is a platform stack and 2 application stacks. And this program defines just a collection of steps of deployment. Like I want to deploy these 3 steps in sequence. And then there is just a for each loop, which says if it's not a destroy operation, just go ahead and for every step in this array, just go ahead and up this command. So the way you drive this is you just go to this command line, you type .NET run, you execute this program. There is no CLI anywhere. You can do it from your CI/CD system. You can write a web service which will do this on request, like provision a new database per new customer of your product. You can be as creative as you want and just drive the whole deployment from your IDE, but still be in full control and use all the benefits of the desired state configuration. Just to quickly show you how this execution looks like. I don't have time to actually run it. Maybe I can run it but not wait until it finishes. So I just type, make it bigger again. I'll just type .NET run in this folder where I'm in the automation API folder, and it runs the .NET application that I have, and it starts deploying my platform stack first. Then it will go ahead and deploy applications after this is done. And you can control the output. This is just some default output. You can do like a Windows application that shows some progress if you want, and so on and so forth. It's just your imagination that is the limit here and your requirements. So with that, thank you very much for listening. Pulumi is open source and free to use. You can learn more about Pulumi at pulumi.com/Azure, and I'm happy to answer any questions if you have some. Thank you.
Wow, awesome. Thank you very much. Wow. So I think we had a couple of questions, but I'm going to be greedy and just ask my own question because this was all very interesting to me. So it's a three-part question. So if you imagine I'm new to Infra as code and I'm new to cloud native databases or services, and I'm looking at this and my head's kind of exploding right now. So I'm thinking I'm used to older tools like Ansible maybe, or maybe I've manually provisioned environments or whatever. What would be the number one reason that you would give them to say you need to make this paradigm shift to doing this? That's part one. Part two would be, is it any easier, or what makes it easier to use services like Cosmos DB with these approaches, if it is easier? And then the last thing would be any pitfalls that you would say, watch out for when you're using this approach that you might not expect from what you've been used to in the past.
Well, to the first part, you need to separate learning the infrastructure itself, like learning what Kubernetes is and what kind of object you need to deploy there, and like all the Azure services that you need, from learning the tool. And my point is that you sort of cannot avoid learning the infrastructure in your company. Somebody has to have this knowledge, but then you don't have to make everyone learn that. You can also just, as I described, have some people specialized on nitty-gritty details of those services, and then they can explain to others and provide abstractions to others so that they wouldn't have to be Kubernetes experts in order to be able to deploy their hello world with code. And because application developers will feel very familiar with the tools and like the code and the C# and so on, they will be more willing to actually jump ahead and like start using this, in my opinion. So the Cosmos DB is great. I tried to illustrate this by using MongoDB API specifically, because like you get all the upsides of like the whole ecosystem built around MongoDB. When somebody built that Helm chart, like they didn't know I'm going to use it with Cosmos DB 5 years down the road. But you still get all the benefits of very flexible cloud environments where you are operating in. So you can create Cosmos DB for your, let's say you open a new PR for your system, you create a new environment with this tool, like you run your tests, you tear it down, you pay maybe 5 cents, I don't know how much, but you don't pay anything basically. And you still got the MongoDB, which can be comparable to your production environment if you want to. So you get like the full power of cloud and the full power of third-party tooling or like community tooling that you get. And the third question was the pitfalls, I guess. Yeah, I guess the first part is like the main pitfall is that you need to get through the initial barrier of like being not too overwhelmed with all the fancy words that I throw in my presentation, and this is like 1% of all the things that exist out there. So I think like putting folks into a more familiar environment is helpful, but of course that's a learning curve that everybody has to take through, and like they shouldn't take it too lightly.
Cool.
One question that we got that's probably just worth mentioning for everyone viewing is, what is the best way to get started if you want, if you're completely new to infrastructure as code and you just want to get started from scratch?
So on my last slide, there was a link, pulumi.com/Azure. From there, you can get to like a getting started guide. From there, you just deploy a very simple, like not that involved application that actually a very simple storage account with a static website or something. And from there, you can get started. After you complete that tutorial and you already feel the workflow of how you provision new environment, how you make changes, how you destroy, since you can already jump ahead to like more advanced scenarios based on your interests, like Cosmos DB, Azure Functions, AKS, whatever.
Great. See, we're at time here, but thank you so much for your session. And
thank you, my pleasure.
Yeah, thanks, Mikhail.